Hello ladies and gentlemen, welcome to the Mal tutorials. In this video we're going to talk on permutations, combinations and the probability. So firstly we're going to define what is permutations, combination and probability. So let us start with permutations. So permutations, it is an arrangement of a set of objects in a specific order, and therefore the key principle of permutations is order. So what matters in permutations is the order. And then the permutations is having two formulas. So in permutations we're having two formulas. The first formula, our first formula under the permutations is NPR, which is equals to n factorial over n minus r or factorial. So this is our first formula under the term permutations. And then our second formula under the term permutations is n factorial, which is equals to n multiplied by n minus 1, then open another bracket of n minus 2 up to n equals to n. So these are the formulas which we use when we are dealing with the permutations. And then we are also having the combinations. So the combinations, in combinations, it is an arrangement of a set of objects where order doesn't matter. So it's like this is the vice versa. Like in permutations the order matters, and then in combination, when we are dealing with permutation, the order doesn't matter. And then in combinations we are also having a formula, and then in combination we are only having one formula. So combination, we are only having one formula, which says n choose r is equals to n factorial over n minus r factorial multiplied by r factorial, where n is the total number of objects and r is the ways to choose. So n is the total number of objects given, and then the r as the ways to choose or pick. And then all these data we are going to be given. So the total number of the objects or the letters we are going to be given, and then the r again, the ways to choose, are also going to be given when we are solving the permutations and combination. And then let us go on the probability. So probability is equals to the favorable outcomes over the total number over the total possible outcome. So this is these are the formulas for the permutations, combinations and the probability. So let us say we are having the letter or the word head in capital letters, and then we need to find the permutation of this word. Now we need to demonstrate and see how we use this permutation, combination and the probabilities formulas which you have written here or on top. So now we need to find the permutations of this word head. So when we say we need to find the permutations of this word head, it means we need to find how many ways can we write this name in different ways. For example, what I'm saying here, let's say this word head, we can start it by writing it in this way, or we can also write it in this way, or we can start with A and then H T, or again write it A T H. We can also write it in this way, T H A or T A H. So 1 2 3 4 5 6. So we are going to find that we are having the value 6. So this is how we find the permutations of a certain thing which is being asked. So when we are being asked that we need to find permutations of a word like this one, we need to find the ways how we arrange that word in different ways. So that's the permutations. So we can also use this formula on the permutations, because we have agreed that on permutations we're having the two formulas. So when the question says we need only to find the permutation, that's when we use this formula. Because we can't use this formula. Why? Because this formula is involving the n, which is the total number of objects, and also the r, which is the ways to choose. And then when the question says find the permutations, we are not given the ways to choose. So there's no need to use this formula because it is including the ways to choose. However, here we only need to find the permutation, the ways to arrange a certain letters which are given in a word. So there is no need to use this formula in such scenario. So now let us use this formula. So when we are using the formula, we say n factorial. So we have agreed that the n is the total number of objects. So here it will be referring to the total number of the letters which are given here. So on this word yet, we are going to say that we are having 3 letters, meaning to say we are going to write 3 factorial. So if you are having your calculator, you can punch 3 and then second factorial, then on 4. That's where that's where the factorial is, which is equals to 6. Or you can say 3 factorial is the same as by saying 3 times 2 times 1, which is equals to 6. This is what 3 factorial means. So even if it's 5 factorial, we start from 5 times 4 times 3 times 2 times 1. It ends at 1, we don't go to 0. So it only starts from the given number that's given, going down up to 1. So this is how we find the permutations. So now you can find the permutation this way, or you can also use the tree diagram to find the permutations. For example, here we're saying on head, you can develop your tree diagram here, and then you say if you start with the letter H, because we're having 3 letters here. So if you start a word, which is if you start by writing H, so it means it's going to be followed by A or T. And then if your letter is having H, A, now it means the T is the one which is going to follow. And then another one is going to have H, T, meaning to say now it's going to be followed with an A. And then here we're having A, so meaning to say the next is going to be either H or T. And when you are having A, H, meaning to say the value which is left here is T. And then here we're having A, T, meaning to say the letter which we are not having here is H. And then you're going to do the same again on T. On T is going to be either A or H. And then here we're having T. If you go with this branch, you can see that we're having T, A, and then meaning to say H is going to be following. And then here we're having T, H, meaning to say it's going to be followed with an A. Now we can count here the tree we're having here, the branches we're having 1, 2, 3, 4, 5, 6. So we are having 6. So this is how we find the permutation. But now let us say if the question says how many times to choose 2 letters from the word. So we are saying, let's say the question says how many times to choose 2 letters from the word yet. This same word. Now we are being asked to find how many ways can we branch these 3 letters into 2 in different ways. So now what it means is that this is where when we go here on permutations, if we need to use the formula, is when this formula is going to be valid. Now we're going to use this one, and then we're not going to use this one, because this one we only use it when we only need to find the permutations. But on this one, the question needs us to choose the letters. The letters we're going to choose, meaning to say now the R, we're having R, the ways to choose. So the permutations, on permutations, it means we are going to use n. Our n, which is the total number of the objects. Here is the total number of letters, which is 3. So we're going to say 3 P, and then the R is the ways to choose, so which is 2 equals to 3 factorial over 3 minus 2 is going to be 1 factorial, so which is 1. So we're going to left with 3 factorial, and then we have figured that 3 factorial is 6. So this is how we find the permutations when the question is saying, this is the ways how to find the ways under the permutation formulas. So now we can also do this by just arranging the letters. So because the question is saying we need to choose 2 letters, we need to arrange 2 different letters. How many ways can we arrange? So the question is saying, the question is demanding us to find how many ways can we arrange, or can we group the 2 letters, the 2 different letters of this word. For example, we can arrange it like HA, or we can say AH. We can also arrange this as AT or TA. We can arrange it as HT or TH. So here, if you count 1, 2, 3, 4, 5, 6, it's 6. So this is what our question is asking. We can also use the combination here. So on the combination, we say the formula for combination is n choose r, which is equals to n factorial over n minus r factorial multiplied by r factorial. Now, if you look here, we've agreed that our n is just 3. So we're going to say 3 factorial over, and then here below we've said that n minus 3 is 1 factorial, which is just 1, and then r factorial means 2 factorial. So if you will say, because we have agreed that 3 factorial is 3 times 2 times 1 over 2 factorial is 2 times 1. So these ones are going to cancel. We are going to left with our answer, which is 3. So we're going to find that on a combination, our answer is 3 here on this question of how many times to choose 2 letters from the word yet. So what it means is this. Now we need to give a clarity on this thing of combination and permutations. Now we are saying that on permutations the order matters, but now on combinations, on permutations the order matters, but on combinations the order, it doesn't matter. For example, here, if we need to arrange this, that's why you see that our answer is different here. When you are dealing with this, the same question, with this the same question, our answer is different here. Here on the permutations we're having 6, and then here on the combinations we're having 3. What it means is this. Now on combination, this one is taken as one thing. It's the same thing on combination, like HA and AH. Yes, so it was supposed to be AH. Here, HA and AH. It's just the same thing. The order doesn't matter. HA and AH is just the same thing. But on permutation, the order matters. You can't say it's just the same thing on when we are on permutations. Because we have started with H and then A, and then on the second is now H is now AH. So it's a different thing. But on combination, it's just the same thing. Like the same as here. So it's 1, 2, 3 when we are dealing with the combinations. Because on combination, the order doesn't matter. So that's the difference which we are having on combinations and the permutations. So now let us go through the examples which we are having on permutations and combination and probability, so that you understand this concept of permutations, combination, and probability. So our first example is saying, how many distinguishable permutations are there of the word mathematics? So here the question is saying, how many distinguishable permutations are there of the word mathematics? So here we need to find the permutations, and then we have agreed that when we are dealing with the permutations, and the question says just find the permutations when we are not having a clue word of choose in that statement, it means we are going to use that formula of n factorial. So what it means here is that here on this example, we are going to say we're going to use this formula of n factorial, or we are going to arrange these letters in those different ways. But if you count these letters, we're going to see that we're having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here we're having 11 letters. So if we need to arrange these letters in different ways, we're going to see that it's going to be too long. So meaning to say we are going to use this formula only for of n factorial. So here we're having 11 letters. What it means? So it means we're going to say 11 factorial over. Now we are going to say over. Why are we dividing now? Because if you check back on the first explanation, when we were dealing with the letter yet, we were not having the repeated letters. But now if you check here, we're having the repeated letters, like we're having repeated M, we're having also repeated A, we're also having the repeated T's. So what it means is that here on the 11 factorial, we have included these repeated letters. However, these repeated letters, they form the same weight. Like this M, when we take this M again, it's going to form the same letters, and then this T is also going to form the same letters, which is also going to be formed with this T, as long as also with the N A's. So what it means is that to solve this, we are going to divide with the number of the repeated letters here. Like here on M, we're having how many numbers? 2 repeated. And then again on A, having 2, and then T, that's 2. So now this is the answer. That's the answer which we are going to get here. If we say 11 factorial all over 2 factorial times 2 factorial the answer which we are going to get here is 4,989,600. So this is the answer which we are going to get on the first example on the distinguishable permutations. So now let us go on the second example. You are free, you can practice, try it on your own. So on the second example, example 2, solution. So on the second example, the statement is saying if there are 20 people in a bike race, it's saying if there are 20 people in a bike race, how many ways are awarding a first, second, and third place medal, assuming no ties? So if we look on this question, we're going to see that this is a question which needs a solution from the permutations. Why? Because here we are mainly focused on the order, because we are mainly focused on which one is going to be the first, which one is going to be the second, which one is going to be the third. There is no way the way we are going to choose the third is going to be the same way which is going to be with the first. No. So on this question, or on this example, we are focusing on the order. So when we are focusing on order, it means that question is under the permutation. So when it's under the permutation, we are going to use the formula of the permutation. But now we have to also know that on permutations, we have agreed that permutations is having two formulas. The first formula is NPR, which is equal to n factorial over n minus r factorial. And then the second formula is that of n factorial, which is equal to n of n minus 1, n minus 2. So now what it means is that now we need to only choose 3 people from 20. So meaning to say here we're going to use this formula of choosing, because we are choosing 3 people from 20 people. Therefore it means here we are going to say our n here is going to be equals to 20, and then our r we need to choose only 3. So it means here we're going to come here and then we say example 2, which is going to be our n is 3, our n is 20, p our r 3, which is equals to 20 factorial over 70 factorial, obviously. Then if you punch this or on the calculator, we are going to get 6,840. Punch this on the calculator. So you have agreed that the factorial, those who are not seeing the factorial, you see that if in the factorial we say 20, then you punch the second function pattern, and then you come here on 4, on number 4. On this 4, you're going to see the n factorial. That's when you press for the factorial, and then we're going to see the factorial on the calculator. That's how we press for the that's how we punch for the factorial. And then let us move on the third example. So the third example, if you look the second example, the second example is saying if there are 15 people in your class, in your chess team, how many ways can you choose the 2 co-captains? So here we are having the chess team, and then on the chess team we need to only choose 2 co-captains. But if we take this scenario logically, there is no need for order. Like, even if we start choosing, the person which is going to be chosen at first is choosing on the second, there will be no any difference, because these people, they are going to do the same thing. They are all going to be the co-captains. They are all going to be on the same level. So there is no need for order, because the first one which is going to be chosen, even if we choose that person as the second co-captain again, there will be no problem. It's not going to make any difference. It's different from the second example, because if we look here on the second example, if this first is going to be the third, there's going to be a difference. There's going to be a difference, because maybe this one is going to be given gold. So it means maybe this one, maybe the number one is going to be given is going to be awarded the gold medal, and then this one is going to be given maybe what you call the bronze, and so on. So what I'm more concerned with is that we have to see where to use the permutation formula and the combination formula. So you use the permutation formula where the order matters. That's where you use the permutation formula. On the scenario where the order doesn't matter is where you use the combinational formula. Like here on the example 3, we are saying that we only need to choose 2 co-captains from a certain group of 15 people. So, and then we are saying that there is no order in choosing. We only just need to choose one. Even if you make it vice versa, that the best person who has been chosen at first is going to be chosen on the second, it's not going to make any difference. So now we are going to use the combinational formula, which says n choose r, and then from the given data, n is the total number of people, that's the total number of objects, that's 15, and then the r, we're saying that's the ways to choose. So we are choosing 2 people from 15, which is 2. So now it means it's from this in our substituting in our formula, it's 15 choose 2. So 15 choose 2, which is equals to 15 factorial over, here we're going to say n minus, because the formula says n minus sorry, let me rewrite the formula. I didn't write the formula. The formula says n factorial of n minus r factorial multiplied by r factorial. The formula says n minus r, which is 15 minus 2, which is 13 factorial multiplied by the r is 2 factorial. So what is going to be our answer here on example 3 is going to be 105 on example 3. So now let us move on example 4. The example 4 says that in a school, example 4, says in a school board, if a school board has 8 women and 4 men, how many ways can a committee be formed with 3 members such that A, all 3 are men, B, all 3 are women, C, 2 women and a man, D, at least 1 is a woman? So how are we going to deal with this one? So with this one, it's just the same as on example 3, because here we need to form, we need to make a committee which is having 3 members. So we are going to choose those 3 members from the men and the women, and then we say there is no order, especially in choosing these things of a committee. There is no order. The order doesn't matter. If the last one is going to be chosen at first, if the person which is chosen at first is going to be chosen at last, it's not going to affect, so long we are having 3 members in that committee. So solved there. So it means here on A we are going to use the combinational formula. So our combinational formula says n choose r is equals to n factorial of n multiplied by r factorial. Here, and from the given data, we are given that how many men are we having? We are having 4 men. And then we need, from the formula, we need 3 members. So it means our R is equals to 3 members. That's R. We need to choose 3 members from these 4 men. So now it means on A is we're going to say our N is 4. So it was supposed to be N here. So it's 4, choose 3. And then on this one, guys, this one is a longer method. We can use the shortcut method here. If you say, we can say 4, then you press second function, and then the choose function, the choose letter, we're going to find it here on number 5. So if you press 5 here, you're going to see it's showing a C, which is a choose. Sorry, there is something went wrong with my calculator. So what I'm saying is that if you press 4 and then second function here on number 5, then you press button number 5. So you press the number 4, and then for you to have this choose, you press the second function, then you press number 5. So on number 5, that's where when they choose, then the choose is going to appear on the calculator, and then you press 3, we're going to get 4. So 4 is our answer on A. So on B, let us go on B. So, and then if you look here on B is saying all 3 are women. So now we are choosing those 3 members from the women. So now from the women, the N is going to change, because on N, women we're having 8 women. So our N is going to be 8, because we are choosing those 3 members, those 3 members from the group of 8. And then our R is going to be 3. And then it's when N choose R. And then we said our N is 8, choose 3. So now we come again on our calculator. And then I will say 8, second function, then you press 5, 3. It's going to give us 56. And then on C say 2 women and a man, because we need 3 members. So now we are being given that for those 3 members, now we are having 2 women and a man. So how are we going to deal with this one? Now what we are going to solve it in this way. We are going to say women. How many women are we having? So we are having N, 8 women. And now on the women, we are choosing 2 women. So our R is going to be, and then it's written and then a man. How many men are we having? Having 4, and then we need to choose 1. So meaning to say now we are going to say 8 choose 2 multiply, or this is and means multiply by N 4 choose 1. Then which answer we're going to get? What answer we're going to get here? So we are going to get 112. It's our answer here on C. And then on D, so this one is going to be different, which is saying at least 1 is a woman. At least 1 is a woman. So on at least 1 is a woman, we're going to say the total minus the non-woman. That's how we solve this one. At least 1 is a woman. So the total, we're going to say the total ways. So the total ways is that a woman is the total number of all which you are having. So we're going to say 8 plus 4. So on 8 plus 4, we're going to find that our N is 12. And then we need to choose 3. So R. And then the non-women. The non-women, we've already having the answer for non-women, because the answer for non-women is all 3 are men. That's the non-women. So for the non-women, we are having on A, who is our A? Sorry, this is 4. We're having 4. So we're having 4. So what it means is that we are going to say NCR minus NCR, where this one is 12C, just choose, it's not C, choose 3, minus our N here, we've said this 4 choose, so our answer is going to be 4 here. We've already if answer, because we said this is on A. So we are going to say here on the calculator, our answer is going to be 216. So this is how we solve this thing of combinations and permutation. Now, so on this last example, we are free. You can practice this one. You can try this one on your own. Solution. So you are given a statement which is saying, how many ways are there of being dealt a 5-card handout of a standard 52 card if A, all cards are numbered, B, contains exact 1 ace, C, no ace, D, all diamonds or all clubs, E, what is the probability of being dealt at least one first card? So firstly, what I think is the best here is to represent how these cards are there. So these cards, they are in this way. We are having what we call the numbered cards. And then on the numbered cards, we're having what we call the first cards. And then you're also having the ace. Under what? These ones, they are under, we're having what we call the clubs. So what we call the clubs, I know mashisha. I'm not mashisha. These are the clubs. And then you're also having the hearts. I'm a moya. And then the shavels, my foshura, and follow under my blakes, and then the diamonds. So we're going to see that we're having 4 groups. Yeah. So tine form a group, tine mashija, mamoyo, mafoshora, then nema diamonds. And then on the numbered cards, so on the numbered cards we're having 1 up to 9 on the numbered cards, and then so on the numbered cards we're having 9 on clubs, we're having 9 on hearts, we're having 9 on shavels, we're having 9 on diamonds. And then on the first cards, so for my first cards, my cards and my faces, my cards and my faces, because for my cards, my cards and my faces, D Jack, Queen, na King. Yeah, these are the 3 cards. So here it means we're going to be having 3, 3, 3, 3. And then on the ace, we're only having 1 ace, 1 ace, 1 ace. So we're going to say that if you add all of this, we're having the total number of cards is 52. That's the total number of our cards. Because here we're going to end up with the total of 36. Here we're going to have the total of 12. Here the total of 4. And then if we add here, if we say 36 plus 12 plus 4, it's 52, the answer. So the total number of the cards is 52. So now, after having this data, now let us deal with this one. So on A, all cards are numbered. So how many ways are there of being dealt a 5-card or 5-card handout of a standard? We need ways on choosing the numbered cards. So meaning to say, if you look on the numbered cards, how many numbered cards are we having? We're having 36 numbered cards. So the total number of numbered cards is 36. And then as we need to choose how many cards, we need to choose 5 cards. So meaning to say, when we need all numbers and all cards are numbered, so we need to take, or we are choosing 5 cards, but mainly focus on the numbered cards only. So meaning to say, we are going to consider the total number. On N, we are going to consider the total number of the numbered cards only. So the total counts of the numbered cards is 36. So that 36, so we're going to choose those 5 cards from the 36 cards. So meaning to say, we're going to say on the formula N, choose 4. So N choose R, which is going to be 36, choose 5, which is equals to 376,992. So then on B, contains exact and A. So contains exact and A. So this one, they are saying that on those 5 cards which you are going to take, it contains exact 1 ace. So it contains exact 1 ace. So meaning to say, on that cards we are going to, so let us first deal with that one. So how many aces are we having here? We're having 4 aces. So meaning to say the total number of aces we are having is 4. But on these 4 aces, we are being told that there's on the 5 cards. We have been told that we are going to choose 5 cards. But here the statement is telling us that on these 5 cards we are having only 1 ace. We are only having 1 ace. So meaning to say, only to deal with the ace, and then the total number of the ace is n, and then the R for A is 1, because we are going to choose only 1 ace. So meaning either this one or this one or this one is going to be chosen. The other option which we are having here is that the option which we meaning to say, now we are only left with an option of the non-ace. How many non-ace? So to find the non-ace, we are going to say 52 subtract by 4 A's. So the non-A's is 48. And then the R, for the R, boss, we have been told that we need to choose 5 cards, and then we have been told that we're having exactly 1 ace. So meaning to say the other 4 cards, they are going to be focused on the non-ace, which is 4. So meaning to say here we are going to choose, because here we are being told that on those 5 cards, on the 5 cards which are going to choose, there is going to be 1 ace. So meaning to say that 1 ace, so meaning to say we are going to be focused on R, where we are having 1 ace, and then the total number of the R's. And then we are going also to deal with the non-ace, which are 48. And then on the non-ace, we are going to left with the conditions of choosing 4 cards. So now the ways which we are going to say NCR and NCR again, which is our N, our first N is 4, choose 1, and it's meaning to say multiply by 48, choose 4. So our answer here at the end is going to be 778 320. So this is the answer. This is the answer. Now let's go on C. On C says all are diamonds or all are clubs. Now they are saying that on those 5 cards which are going to choose, those 5 cards, they are going to be all of those 5 cards are diamonds, all of those 5 cards are going to be clubs. So meaning to say we are going to say, oh, if all of them are going to be diamonds, it means the total number of the diamonds, if you come here, the total number of the diamonds is 9 plus 1 plus 10 plus 3 plus 13. So we're going to have 13. And then the R, we are choosing 5 cards. All are clubs. So on the clubs, Mashisha, we're having also N is equal to 13. And then you're also choosing the same 5 cards. So meaning to say, we're going to say, now we're going to say the N, choose R plus N, choose R, which is 13, choose 5 plus 13, choose 5. And our answer is equals to 1412304. So this is how we find these ways. And then on the last one, what is the probability of being dealt at least 1 first card? Now we are going to see that this question, you can try this on your own. You can try this one. You can you are free to pause the video, and then you can try this one. So on this one, it's actually different from the other ones. Because on the other ones, we're dealing with the ways. Understand? But now we are dealing with the probability. This one is saying the probability. What is the probability of being dealt at least 1 first card? So now, when we are dealing with, we know that when the question says at least 1 first card, it means either 1 first card up to infinite. You understand? So up to it's gonna be 2 first cards, 3 first cards, 5 first cards. So that's the thing. So now, when the question says at least 1 first card, we can say in probability we say 1, because this one is, we call it the complement rule. We say the complement rule. So here what we do is that we say, when it says at least 1 first card, we say 1 minus the non first card. This is what we call the complement rule. So we are going to say this one, the ways to choose the probability of choosing the non first cards. So we have agreed that probability is equal to the favorable outcomes over the total favorable. So what it means that now we're going to say our favorable outcomes. Our favorable outcomes is that we need to choose the favorable is that we need to choose the 5 cards from the non-first cards, and then we've agreed that the first cards, these ones, the 3s, is they're 12. So we're going to say 52 minus 12. We're going to get 40. Therefore, it means the non-first cards are 40. So I'm going to say the N for the favorable outcomes. So let me say the favorable outcomes to make it simple. The favorable outcomes. So for the favorable outcomes, I'm going to say for the favorable outcomes, we are dealing with, say that when the question says at least, you're going to choose the complement rule. So on the complement rule, we are going to deal with the non-first cards. So for the non-first cards, we're going to say the N for the non-first cards is 40, and the R is 5. We're going to deal with, and then it will be over the total possible outcome over the total possible outcomes. And then on the possible outcomes, we're going to say our n is 52 and then our r is 5. Therefore, it means now on the probability, we're going to say 1 minus the favorable outcome, you say it's 40, choose 5, over 52, choose 5 again. And then our answer here, if you find the value, is going to be 0.747. So this is how we dealt with the permutation combinations and the probability. So on the next on my next video, I'm going to deal with a variety of questions which are involving the combination, permutations, probabilities. For example, the type of questions here I'm saying is like this one, because if you look on the questions starting from this D up to the example 1, we're dealing with the ways which are the things, or which are the bases which we use in the probabilities, which include the permutations on probabilities. So meaning to say, on my video we are going to look on the probabilities which include the permutations and probabilities, where we are going to use those those ways, because these ways are the tools which we use to find the probabilities which include the permutation and combination. Thanks for watching, guys. Don't forget to subscribe, like and share.